Welcome back to Oddity Farming, the place where we uncover the hidden systems that grow the food on your plate. Quick question: what fish is quietly taking over dinner tables worldwide? Not salmon. Not tuna. A humble, fast-growing fish that thrives in warm water and turns feed into protein with amazing efficiency. Tilapia. More than 5.5 million tons a year. And in China, where most of the world's tilapia is raised, fish farms now look less like ponds and more like high-tech factories. Cameras watch fish 24/7. Sensors track oxygen, pH, and temperature. Algorithms decide when to feed and how much. Entire farms run like smart cities underwater. Today we will uncover how China breeds, raises, harvests, and ships tilapia at massive scale, why AI is at the heart of it, and what this means for price, taste, jobs, and the planet. If you love clear, science-backed stories about food and farming, tap like, hit subscribe, and ring the bell so you never miss an episode. Tilapia's journey starts with carefully selected parents. Breeders cross strong, fast-growing lines and keep only the healthiest broodstock. The goal is simple: fish that grow quicker, convert feed better, and resist disease. Females carry fertilized eggs in their mouths to protect them. Once the tiny fish hatch, technicians gently move them to nursery tanks. Here the water never sleeps. Oxygen, temperature, and pH are controlled by automated systems. If oxygen dips, injectors switch on. If temperature rises, alarms trigger cooling. The fry eat tiny, high-protein feeds several times a day. Smart feeders watch behavior and stop the moment fish lose interest. That keeps water clean and feed waste low. In a few weeks, small fingerlings are ready for bigger homes. Next step: grow out. Some farms use traditional earthen ponds with good natural sunlight and algae growth. Others run recirculating aquaculture systems, closed loops that filter and reuse most of the water. These systems pack more fish in less space without constant water exchange. Biological filters remove ammonia. Mechanical screens trap solids. UV or ozone knocks down harmful microbes. Because conditions stay stable, fish grow faster and stress less. AI sits in the control room. Cameras watch how fish school, how quickly they rush to feed, and even subtle changes in movement. Software spots early disease signs, adjusts feed rates, and keeps oxygen levels steady. The result? Fewer antibiotics, more uniform growth, and predictable harvest dates. Daily care is simple but strict. Workers test pH, ammonia, nitrite, nitrate, temperature, and dissolved oxygen. If a pond drifts acidic, lime balances it. If oxygen dips at night, aerators spin up before fish suffer. Cleaning routines keep gear disinfected. Any weak or sick fish are removed fast to protect the rest. Many farms add probiotics to support gut health and water quality. The guiding rule is consistency: stable water, steady feeding, and calm fish. That is how you turn small fingerlings into market-sized fish in 6 to 9 months. Feeding is the biggest cost, so precision matters. Pellets are engineered with the right protein, fats, vitamins, and minerals for each life stage. Too much feed means dirty water and wasted money. Too little feed slows growth and pushes harvest back. Smart systems solve this. They learn each tank's eating rhythm, pause when pellets float, and ramp up when fish are active. Some setups even track feed conversion in real time. Better feed control means cleaner water, faster growth, and healthier fish. When harvest day arrives, timing is everything. Smaller farms use seine nets and skilled crews. Large farms deploy gentle harvesters that move tons of fish per hour with minimal stress. The fish go into oxygenated tanks or trucks with continuous monitoring of temperature and oxygen. The goal is a short, calm trip to the processing plant. Keep the chain cold, Keep the fish calm, keep quality high. Processing looks like a choreographed dance. Fish arrive, rest briefly in chilled water, then move through stunning and bleeding for humane handling and better meat quality. Scaling, gutting, and filleting are done by trained teams or precision machines that turn out uniform fillets. X-ray or optical systems catch stray bones and defects. Fillets are chilled or flash frozen quickly to lock in texture and flavor. Packaging varies by market. Vacuum packs for retail, IQF for food service, portions for restaurants. Many plants now track each batch from farm to box with digital IDs, building trust with buyers and regulators. Why does this matter globally? Because tilapia hits the sweet spot. Mild flavor, lean protein, and a price most families can afford. It works in steamed Asian dishes and in grilled tacos. As quality and traceability improved, premium options, like low antibiotic or organic lines, pushed into higher-end stores. Behind the scenes, this industry supports rural jobs, export revenue, and food security. For many countries, affordable fish protein is not a luxury. It is the backbone of weekly meals. Sustainability is the big question. Tilapia has an advantage. It eats plant-based diets more easily than carnivorous fish, so it does not rely heavily on wild fish meal. Closed-loop systems reuse water and capture waste. In-pond raceways concentrate fish and make waste easier to treat. When farms follow best practices, good siting, proper effluent treatment, careful stocking, they can produce a lot of protein with a smaller footprint than many land needs. The risks are real though. Poorly managed farms can pollute waterways or crowd wetlands. Energy use can jump in fully closed systems. That is why monitoring, certification, and transparent audits matter. The best farms measure everything and improve year after year. AI changes the game further. Imagine disease detection before symptoms. Feed tuned by behavior, season, and even weather. Predictive harvest windows that match factory schedules and shipping slots. Less waste. Lower cost. Better margins. For small farmers, simpler tools help too. Affordable probes, solar aerators, and phone-based apps that flag risks in time to act. Technology should not replace farmers. It should make their decisions sharper. Let's talk about taste and safety. Clean water and quick chilling equal mild, fresh flavor. Buyers want firm fillets with no muddy smell. That comes from stable ponds, proper aeration, and fast processing. Safety standards are strict for export. HACCP plans, sanitation checks, residue testing. When you see labels like BEP or ASC, that means an independent group audited the farm or plant. More retailers now require these badges before they buy. What about the cost? Feed, oxygen, energy, and labor decide the price. Tech looks expensive, but it pays off if it cuts feed waste and losses. Recirculating systems use less water but more electricity. In many places, farms add solar or biogas from fish waste to offset energy and shrink their footprint. Margins are thin, so efficiency is not a buzzword, it is survival. Another big shift is in the product mix. In local markets, people still buy whole fish fresh off the ice. But for export, fillets rule the game. Easier to cook, easier to portion, and perfect for global kitchens. Now, value-added lines like seasoned fillets, breaded bites, and vacuum-sealed ready-to-cook packs are booming. Families want fast, healthy meals, and tilapia fits right in. Every upgrade, from automation on farms to smarter cold chain tracking, helps that fillet stay safe, fresh, and profitable by the time it reaches your plate. Thank you for watching Oddity Farming. If this opens your eyes to the science behind affordable seafood, tap like, subscribe, and hit the bell so you never miss our deep dives into modern farming. See you in the next one.